How can amateurs get involved in astronomy? Does the Milky Way ripple? And would Gaia work better if we put it out at Jupiter? All this and more in this week's Overtime Question Show. Hey everybody, summer continues, but we're almost over. So I'm going to talk about what the plans are to come back to our regular live streams at the end of this episode. All right, let's get into this week's Overtime Question Show. Thomas Quick, I'm a software engineer with 17 years of experience. Are there any ways I can help astronomy with my skills? Absolutely. A lot of astronomy, modern astronomy these days is programming, computer programming. Like a lot of astronomers are also very good computer programmers. There's tons of really good programming libraries in Python that astronomers have to work with. When you think about all of these like really big databases, upcoming Vera Rubin's going to be releasing petabytes of data onto the internet, the Sloan Digital Sky Survey, Gaia, like a lot of astronomy is giant database queries. And so astronomers are often limited by the amount of computer ability that they can do. And so, I don't know how to connect you directly with astronomers who need that kind of help. It'd be cool if there was a way to connect software engineers with astronomers who need software engineering help. But it's the two just go hand in hand. So a thing that I recommend as a way to sort of cut your teeth is do some data visualizations. Start to learn how to access where the Gaia data is, where the James Webb data is, where the Hubble data is, the Very Large Telescope, and do some interesting things. Like my friend Dylan O'Donnell, he downloaded all of the Hubble observations, just the right ascension and declination for every single observation that had been made by Hubble. And then he just plotted them on a chart of the sky. And that's how I got that 0.5% of observations by the Hubble Space Telescope, was that he counted up the total number of all of the observations that were made in the sky just as a computer processing project. And yet he got a ton of publicity for doing that. So I think, there are projects that if you're interested in, you can go and find them. I recommend you spend some time getting to know the various Python libraries, the data sources, how the FITS works, the format that astronomers use to save their image files, and then start reading papers on arXiv and look for times where people are referencing the kind of computer work that they had to do. And they go, I could help with that. And then you just have to start reaching out for people and say, hey, I'm a computer programmer. I'm really good at giant database queries. I can SQL like nobody's business. Can I help you run some queries on the Sloan Digital Sky Survey and, help you optimize your queries or whatever. And I'll bet you after a little while, you're going to have some people take you up on this, and then you're off to the races. Yeah. I mean, so much of astronomy now is computers that, and then after a while, you'll probably end up on a team. Kevin Gill, who is sort of one of my favorite citizen scientists, he does a lot of renders of Mars based on Mars reconnaissance orbiter images, and he's able to import them into Maya and turn them into 3D flyovers on Mars. Originally, he was a computer programmer and he was doing all of these projects, and he got interviewed at NASA and now works at the Jet Propulsion Lab. He works for one of the Earth observing missions as a developer, and in his free time continues to do all of this image processing work that he does. So I think not only can you help out and get involved, that a lot of these turn into jobs if you could bring a lot of value. So learn the libraries, learn the FITS format so you can download images from databases, and then just start making fun stuff, because astronomers are so busy with analyzing their data of trying to answer some specific scientific question that they don't have time to do the fun stuff. I'm going to take the entire Minor Planet Center database and I'm going to render all of the potential Earth-crossing asteroids in a 3-dimensional plot. And so now you see this real-time thing of all of these asteroids flying around in space. That's really cool, right? So you're well positioned All it takes is just a little bit of elbow grease, but I love it. Potato Biden, galaxies have ripples. The observations show a vertically oscillating disk movement like ripples in a pond. Galaxies do have ripples. So when you look at a galaxy and you sort of imagine the stars are just going around the center of the Milky Way, they actually have an up and down oscillation as well. So stars will go up and down and up and down. Like, think about the orbits that say the Earth versus Mercury versus Venus. Like, they're not all perfectly lined up on the plane of the ecliptic. Some of them are a little higher, some a little lower. And so if you sort of looked back, and you could see, like, sometimes Earth is a little higher, a little lower. And then as the whole solar system is moving around in the galaxy, then you're going to see these planets, at various levels higher or below the plane of the ecliptic. So the same thing goes for stars, that stars are, as all of the stars are orbiting around in the Milky Way, some of them are going higher and some of them are going lower, above and below the galactic plane. And one of the sort of theories for mass extinction events in the past was that maybe the interstellar protection, all of the interstellar wind acts like this general protection that protects all planets and stars from the cosmic rays and the other sort of the interstellar winds that are going on. And so maybe there was a time when the sun had sort of poked up above the galactic plane, was less protected by all of the other heliospheres. And so that might explain why we had a mass extinction. And I think it lines up, like, when the sun went above the galactic plane some X number of millions of years ago, then it might line up with when there was a mass extinction event. But, there's not a lot of evidence that this is the case. Michael Nichols, if we think we have discovered life on a planet in another system, is it any easier or possible to build a telescope specific to examine that system only? Yes, in that the parameters of the star that you're looking at, the faintness of the planet that you're attempting to observe, that you could make sure that your telescope meets that certain minimum criteria. Like, say, the Solar Gravitational Lens telescope, where you use the gravity of the sun as a natural telescope lens. You send a telescope down this very specific cone, which lines up the sun and whatever target is that you want to observe. And then you can only observe that one thing, but you get a 10,000 times magnification from the gravity of the sun. And so, the Solar Gravitational Lens would let a 1 meter telescope make a 1 megapixel image of an exoplanet that is 10 light years away, which is, we would require a 10,000 kilometer telescope to be able to make that same kind of observation. So that's a good example of where, if we knew that we only had this one target that we could actually observe, then we could send the telescope out to the Solar Gravitational Lens and make those observations. So, but in general, if you have like a really interesting target, the telescope that you build is going to be usable for anything that fits the same criteria. And so, if you have one planet that's 10 light years away, which is a Earth-sized world orbiting around a sun-like star, there's going to be 10 of those that you're going to be able to observe with the telescope that you build. But it won't be good for a lot. Well, actually, it would be good for a lot of other stuff as well. So, like, generally, you don't want to get tied down, right? You don't want to just be forced to only use the one specific, one kind of observation. Like, you want to be able to use your telescope for other stuff as well. Levi Rivers, what do you think about the Apple ad that angered the world by crushing the technology and the things that computers have replaced bit by bit? I mean, what they were trying to say was that you could take all of this audio production and all of this music production, all of this movie production and all this kind of stuff, and you can do it with this iPad. And I beg to differ, because iPads are terrible for content generation, in my opinion. Like, it uses the Apple operating system, and it's terrible. Like, Alt-Tab, they can't move between applications, copy-paste. you have to attach a separate keyboard. You might as well just have a laptop. Like, use a laptop like a gentleman. So I see what they were getting at, and man, like, why? I think people are so nervous and upset about artificial intelligence now. And they're sort of expecting that the tech companies see the creativity and the things that people make as just grist for their mill to just feed into their endless maw of artificial intelligence. And that's true, right? Like, it is absolutely coming. I mean, we are approaching the content apocalypse for search engine traffic that has always been looming. My traffic from Google search is about 10% of what it was 10 years ago. And a big reason is because, if you search for what is the distance to the moon or something like that on Google, you're going to get just the answer. You're not going to get a web page that's going to talk about how scientists have more recently calculated the distance from the Earth to the moon. You're just going to get the answer and maybe some references. But once you get the answer, people just want the answer and they just move on. And so that has already existed for, many years and has cut down the traffic from Google. And the next thing that's coming is they're going to have artificial intelligence give you a nice witty paragraph that explains, and it's fed by websites like mine, right? So if you want to read about Fraser's latest news, Google will gladly mash it down into a sort of, an overview, a synopsis. And you don't even have to go to Universe Today anymore. And a lot of people are seeing this as like the final death blow that Google is about to drop, and all the various AI companies, and yet they're fed by our content. And I don't care. I don't see traffic from Google as a right, as an inalienable right that I deserve. It was a sweet bonus that we were able to take advantage of for while it worked. But as you see, I write an email newsletter. I do a podcast. I put out an RSS feed. I maintain a website. I do all of, Patreon, all of these things that allow me to make a personal connection with the audience. And my feeling is that when we do cross that line and a lot of the content on the internet is generated by robots for robots, then that human touch for a while is going to be a benefit. That we're going to have a team of human beings who are going to create, content, and we're going to report, and we're going to interview people who are doing things years before this makes its way into the large language models. And so I think we've got another decade of us being able to create content that's better than the robots will be able to. And eventually there will come a day when the robots do my job better. And I'll know it, I'll feel it, I'll see it, and I will gracefully leave the field and hand over the baton to the robots. I am against bad content, and I am for good content. And I think there's something kind of magical about artificial intelligence being able to create good content at scale, custom for every person who has a question about, you've got a question about space or science or astronomy or whatever, and you want to have some tutor patiently take you through the content in a way that Fraser just doesn't have the time for. And if it's factually correct and it's not hallucinating and it's bringing in sources and it's doing a good job of educating people, then I am redundant and I will retire. I can't wait. That sounds great. Not the retire part. No, the patient artificial intelligence that doesn't hallucinate and provides good information. Because there's a lot of misinformation out there, and to have something that is doing a good job of being truthful, I think will be wonderful. But we're not there yet. And the problem is that people are deploying this stuff way too early. So what did I think about that Apple ad?
It was fine. I don't care. It didn't bother me. I didn't get upset. I didn't get angry. I saw what they were going for. I understood how people thought it was a little ham-fisted. And I don't like iPads very much. That's how I feel. Nostalgia Arcade. I've heard you mention AI hallucinating a few times. Is this real, and what do you mean? AI is a token prediction machine. So when you put in a question in AI, like, what are 10 websites that I can go to that will give me very specific information about modifying 1980s Nissans? Then it will give you 10 websites, and 7 of them will be real and 3 of them will not exist. Like, if you go to type in that website, there will not be a website there because the AI just hallucinated it. It just made it up because it was very sure, very predictive. www, it knew that part. Okay, it's got that part. Now it's got, quick AI, make something up. And so it had to make up the rest. And so you get this just nonsense, 80s Nissan upgrades.org. And so for stuff that's like very well known, there's a lot of data in there. You ask it, where is the Eiffel Tower? It's going to tell you Paris over and over and over again. It's going to say it's in Paris. But if you have a fairly vague piece of information, then the AI could very likely just make something up. And it's very confident about it because it can only move forward. It can never just stop and go, whoa, whoa, whoa. I don't know the answer to this question, right? It just goes, I'm just going to make it up, and I'm going to stand by my answer with incredible certainty. And so that is what hallucinating is, and you just have to know that this is a part of the problem with modern AIs. They hallucinate. Floater 81 floats. If money was no object, is there an upper limit in physics on how large an orbital capable rocket can be? No. I mean, I think you're sort of, after a while, you're wondering, like, how big can you make a skyscraper? Like, there's a point where the structural elements of your rocket are going to be so heavy that you really can't make a flight-worthy vehicle. But when you think about the Sea Dragon, you could absolutely make rockets that are capable of carrying hundreds, maybe even thousands of tons to low Earth orbit. It's just who needs payloads that big and who's willing to put all of their eggs in that one basket. So I'm sure there is an answer to that question, that that there is this sort of sweet spot where, but like as Elon Musk has said with Starship, that the bigger rocket, the more efficient, the more value you get out of it, especially when it comes to reusable. Church discography. Will humans survive the next mass extinction event? We don't know. I mean, we are potentially in the middle of several mass extinction events right now. We are seeing a die-off of life forms on Earth, a loss of diversity. We're theoretically churning through Earth's resources faster than Earth can replenish them. And so who knows what's going to happen. But there's like a lot of different kinds of mass extinction events. An asteroid strike would be devastating, but I think humanity would survive and eventually civilization would bounce back. Even the kinds of things that we're facing, a global nuclear war, some kind of climate change, all of these issues, they are bad, but they're the kind of thing that we can learn our lesson from and recover. But we're starting to enter into this era of the kinds of existential threats that we cannot recover from. So artificial intelligence is one of them, right? Like, if we do successfully make a life form that is smarter than us, how do you think that's going to work out for us? So that is definitely a potential existential threat. And like, I don't think there's a way you survive that. Like, I don't think it's romantic, like the Terminator or whatever, that you are fighting robots in hand-to-hand combat in tunnels. No, you wake up one day and everybody's dead because the computers come up with a plan and it implemented the plan and just everybody's dead. Or the computer just keeps rolling and doesn't care about us, and the Earth becomes less and less of the kind of place that humanity wants to live on, and the robots just don't care. So I think that is, some kind of human-made biological thing, right? A pandemic, whatever, something that is engineered to cause more death and destruction. That seems like the kind of thing that could cause problems. And of course, there's some, potential for some science experiment. And there's another class beyond just mass extinction. There's a class of existential crises, which are kind of horrifying. Like, there's like us wiping out ourselves, or like a lot of humanity. There's us wiping out all life on Earth. And then there's like us wiping out all life on Earth and all future life on Earth, like by destroying the Earth somehow. And then there's like us destroying the universe. Like theoretically, if we unleash an AI horde into the universe that is unprepared, we sort of hand over the future of the universe, the future light cone of the universe, to the robots. So we're in this time when we got to be really careful. And the power for individual human beings to affect large amounts of the universe is growing day by day. Back in the olden days, you had to have some capacity of a nation state to build a nuclear weapon. And, same thing with like some kind of bioweapon. But now, you can imagine 30 years from now, somebody sets, orders all the right parts from eBay and builds a bioweapon and releases it because they've got a grudge, and kills all humanity. So it's a very interesting time that we live in. Federico Nito, any thoughts on the electromagnetic space cannon as a new propulsion system to send stuff to space, or was this answered before? So I haven't talked about electromagnetic cannon anytime recently, but I've interviewed people in the past about it. So people have been proposing this idea that you could use electromagnetism to accelerate a payload to orbital velocity and fire it out of the Earth. There's a couple of ways this takes. One is you have this big long rail where you put a payload on it and then you accelerate it. And then maybe you go up the side of a mountain and then you release it, and you've got enough velocity that it can go to space. Now, the energies involved would cause any, the acceleration would turn any living creature into paste, but robots and stuff, they don't care. They can handle it. Now, there's been a couple of ideas. One is that, you go up the side of a mountain. Another idea is you just like dig a really deep hole, and then you put your payload down at the bottom of the hole, and then you just have it come up this mine shaft, and then it reaches the surface and keeps on going out into space. The problem is that electromagnetic, like railguns, and this is a technology that the US military has been trying to master, try to put these things on their ships, because wouldn't it be cool if you didn't need to fire off big bullets, and instead, you could just shoot metal at your opponents? And the problem is that the forces involved are incredibly damaging to the railgun itself. So you can absolutely fire your electromagnetic railgun, but you can't fire it twice because you have mangled it up after running this much electricity, this much force through these things. I actually did an interview about a year ago with someone who was proposing that you could use like superconductors to be able to try and minimize the amount of effect that you would have on the railgun itself, and so that would be possible. So if you could work out those problems, then you could absolutely build some kind of railgun that could launch payloads into space. Now, one of the additional problems is that you can't get things to space with a single launch. In other words, if you're gonna, if Superman kicked you into space, no matter how hard he kicked you, assuming you could survive the kick and you could make it through the atmosphere, then you would return to the Earth, because the beginning of the orbit is Superman's foot. And so the end of the orbit is going to be somewhere on Earth. You need something to circularize your orbit. And so the same thing goes with an electromagnetic railgun. If you launch this payload into orbital velocity, you still need to have a rocket on board that can circularize the orbit. Otherwise, you're just going to be suborbital. You come back and crash down. You're on a ballistic orbit. In other words, Superman, when he kicks you into orbit, he's always kicking you on a ballistic trajectory. He's not putting you into an orbital trajectory. So I think like railguns are kind of like fusion right? They are always 30 years away. Gary Peterson, is it possible to use the greater parallax of, say, Jupiter to achieve a more precise distance measurement to given further stars? So I get this question quite a lot. Like, Gaia is really amazing and exciting, and it is at the Earth-Sun L2 Lagrange point, which is about 1.5 million kilometers away from the Earth, roughly Earth orbit. And so you get this, you've got the sun, you've got the Earth on one side, 150 million kilometers between the sun and the Earth, and then Gaia orbits all the way around to the other side, and now you've got the another 150 million years. So you've got this triangle that is 150 million kilometers. You can measure the angle to the star, you can measure the parallax, and we can find these things out. Then people wonder, well, could we go to Jupiter? Could we set up Gaia out in Jupiter to be able to do those observations? And theoretically, yes. And it would definitely give you a bigger triangle that you could then measure the parallax measurements, but it wouldn't necessarily let you see dimmer objects. If anything, it would be harder to get a mission out to the orbit of Jupiter that would have the same visual capabilities of Gaia. And so Gaia is partly how accurate it can measure the stars, and partly how big are its optics, so it can actually measure the brightness of the stars to be able to even find these things. And so in many cases, building a bigger telescope might be the better way to get a more accurate measurement than trying to create a larger baseline. And so right now, you're not hearing any proposals to send a future Gaia mission out to, beyond Earth orbit. You're hearing about, well, let's make a near infrared version of Gaia instead of something like that. So right now, obviously the scientists have thought about this, and their preference would be, let's have near infrared as opposed to let's have a bigger telescope, or let's put Gaia farther away from Earth. Thwaites, since you have a bit of land, are you considering upgrading from a telescope to a small observatory? If a large telescope is around 14 inches, you could do 24 to 30 inch scope in a shed. I am planning to build an observatory here. Not like an astronomical observatory. I'm probably going to build something like what we had with the virtual star party. So probably like a 14-inch RASA telescope on a mount that I can control, that I can look out my window and go over, and it's on my Wi-Fi, and it's going to have high-speed connection, and I'll be able to do star parties from that. So I have a plan to bring on some space friends, to consult with them, to make recommendations for what I can do, and then sort of document the journey as we build the thing, and maybe I'll fly them out and they can help build the thing with me. So that's sort of in my medium term, and I'll let you know when I have more of that put together. The problem is that where I live, it rains a lot for half the year. This place is no place to put a telescope. But half the year it's beautiful. It's clear skies, and it'll be great. So that's sort of in the works. Tropical Tom Garcia, have you ever made it through an episode only to discover that you failed to record it? Oh, of course I have. God. So I haven't failed to record it, but the recording was worthless. So that's close enough. In fact, there is an episode that we did fairly recently, about 3 months ago now, that my audio was messed up. So not the guest's audio, but my audio. My computer went through a restart and did an update, and for some reason my audio software thought that it should latch on to some garbage audio. I think there's a little microphone on my monitor somehow. That was the microphone that my audio was going through, and so it just sounded like garbage. And Anton was like, I can't do anything with this. Nobody will want to listen to this. And it's a really cool interview. It's an interview with the chief engineer behind the LISA Pathfinder mission. We talked about how LISA Pathfinder worked. And so at some point, I have to redo the interview. I have to either just come clean and go, I'm sorry to say this, but we botched my audio. And so I am going to, at this point in the interview, I asked him this. And then you'll get his answer. And then I'd be like, and at this point, I asked him that. Or I'll just fake it and just go and just re-record all the bits and pieces and pretend like it's live, pretend like this was the actual interview, like Weird Al Yankovic. So there is nothing more frustrating and more heartbreaking to make something and then realize that you completely messed up the audio. And yet everyone who's ever done this before has made this mistake. And the solution is backups on top of backups, redundancies on top of redundancies. And yet still something messes up and you lose all this work. And we did an episode. Okay. All right. So I'm going to come clean. So we did an episode of Space Bites 3 times. So the first time we did the recording of the Space Bites, it was that same week where my audio had glitched out. And so Anton listened to the audio. He was like, I can't use this. I'm like, oh no. And so I listened to it. I'm like, okay, let's redo it. And then we redid the episode, and I didn't notice, and Anton didn't notice, but I had like a crumb from a sandwich in my mustache. And so we were watching the video afterwards, and we're like, oh, we can't use this either. Like, everyone's just going to go, hey, Fraser, there's food in your mustache. So we threw that one out, and then we recorded again. So we recorded an episode of Space Bites 3 times just to finally get it completed. Will Rose, once ISS is retired, other than the Chinese space station, are there any plans to put a lab way station in Earth orbit? Or will science workload for ISS move to the Lunar Gateway Station? So there are proposals for private space stations. One idea is that they'll attach a private space station to the International Space Station. And then when the ISS is due to be retired, they'll detach the private station and maybe some other modules of ISS, and then that'll remain in orbit. So there are, I can think of like probably 5 proposals for private space stations that are in various levels of development. And so chances are one of those will be flying before the ISS gets deorbited. But if not, then the Chinese will be the only game in town.
All right, I'm going to talk about what is happening here on the channel in a second. But first, I'd like to thank our patrons. Thanks to Abe Kingston, Adam Schaefer, Barry Lake Roofing, Bill, David Giltonen, David Matz, Dennis Alberti, Dustin Cable, Jeremy Mattern, Jim Burke, Jordan Young, Josh Schultz, SpiderSwap.io, Paul Roebuck, Stephen Krasaki, Stephen Fowler Munley, and Vlad Shiplin, who support us at the Master of the Universe level, and all our other patrons. All your support means the universe to us. So summer is almost over, and that means we're going to be coming back to our regular live streaming schedule. And so that includes what we do here on the channel every Monday, when we do the live question show, as well as Astronomy Cast is coming back. Now, I'm not sure exactly when Astronomy Cast is coming back, but I'm coming back on Labor Day. So that's going to be September 2nd, 2024. I'm going to put the show into the calendar so you can see that it's coming, and you can subscribe to the channel, click on the notifications bell, and you'll get a reminder when we're about to go live. And of course, it is a 2-hour show. So we will do the first hour, the one that gets turned into the QA, and then we will record a second hour, which we call overtime, which then we will maybe watch next year. But for the people who watch it on live, you'll be able to see it right then. As well, of course, we've got a bunch of additional content that we're putting over on Patreon. So if you want all that additional content, and you don't have to be a paid member, you can get a bunch of extra stuff just for free. Go to patreon.com/universetoday. All right, we'll see you next week.